So this is a video on trigonometry part 4, and it continues from the previous video of solving trig equations. Now in this video what we're going to do is we're going to go through solving trig equations when sine x, cos x or tan x is not the subject, but also when the x or the theta in these particular equations is a function of itself. So when you've got, rather than having x, instead what you've got is you've got bracket where you've got x plus 15 or x plus 30 or x minus 60, or you've got 2x or 3x minus 15. Now I'm going to show you how, through the examples that I've chosen, to how we go about solving those types of equations. So what we're going to do now is have a go at the following 9 examples. Now in these questions you can see that there's something slightly different. And what I'm going to do is I'm going to show you and talk you through how we go about answering these questions, and also key things to be looking out for. One thing I would also recommend that you might want to do is, after the video, what you might want to do is go back to the screen and have a go at these questions for yourself. Then you can always check your answers to see how much you remember. So let's get started with question 1. So what we're going to do is we're going to follow the methods that were shown in the previous video on solving basic trig equations. So the first thing we want to do is first check to know what our range of answers is going to be. So in this case it's going to be angles from 0 to 360. And as you can see in this particular question we need to make cos x the subject. So the first thing I'm going to do is rearrange the formula so that we've got cos x the subject, and whichever I do that I get minus 2 over 5. So now what I'm going to do now is find the first angle by using the calculator. I know that x is going to equal inverse cos of minus 2/5, and if I type that into my calculator I get a first angle of 113.6. So now what I'm going to do now is do a quick sketch of my cos graph between 0 and 360, which looks something like that. And as you can see from my diagram, it doesn't need to be a complete utter work of art, and it's just a case of giving you an idea of how we can find the second and further equations. So because I want my range going from 0 to 360, that's the reason why I've gone from 0 to 360 in the graph. So if I now draw a horizontal line through to minus 2/5, which I'm going to say if that's minus 1 and that's positive 1, again it doesn't need to be ridiculously accurate, so we're looking for somewhere along there. Now as you can see, within the range that I'm wanting, I can see I've got 2 intersection points, and I can see that from the diagram that the calculator has given me the closest one to the origin, which is 113.6. So what that then tells me is that this distance from the origin is 113.6. Now at the origin it starts at 1, so to find the second angle, this distance here is also going to be 113.6. So to find the second angle, all I need to do is 360 minus 113.6, in which I get my second angle of 246.4 degrees, giving me a final answer of 113.6 degrees and 246.4 degrees, and these angles are all given to one decimal place. So moving on to our second example, just bear with me. So in this particular example what we've got is we've got more complicated sort of values. So again it's worth just double checking to know what range we're working with. So we're working with the range of 0 to 360, and as you can see in this particular example I need to make sine x the subject. So to make sine x the subject, all I need to do is take all of this to the other side, which then leaves me with sine x equals root 2 over 2. So therefore x is going to equal the inverse sine of root 2 over 2, which gives me 45. So working with the sine graph, so I'm going to quickly just do a quick sketch of the sine graph between the range of 360. That's pretty poor, so let's try that again. That's a little bit better. So here we've got 90, 180, 270, 360. And if I draw a horizontal line through root 2 over 2, which I'm just going to assume is roughly about there, I'm looking for two angles within that range of 0 to 360. So from this, all we need to do then is work out what this second angle is. So again, this distance here is 45 degrees. So from the origin it starts at 0, so I'm looking at the next time at 0. So although it's quite tight squeeze, that distance there is going to be 45. So to find this second angle, all I need to do is 180 minus 45, which gives me a value of 135 degrees. So my answer for this question is going to be x equals 45 degrees and 135 degrees within the range, and that's all to 0 decimal places. Now I don't need to worry about rounding because they were their exact values, so we can go on from there. Now with regards to question 3, so again we're looking at the range from 0 to 360. Now the main difference here is that we've now got a trig ratio that involves a power. Now just a little side note, what you need to remember with regards to powers involving trig ratios is the fact that cos squared x is basically cos x squared. Now the reason why we write it like this and why we write the power in between the cos and the x is so that you're not getting confused between this. Now if you write it in this format, it appears that only the x squared is being squared, whereas when we write it in this format here, we're looking for that the whole of the trig ratio is being squared. So that is one of the reasons why we write, when we're squaring trig ratios, we write the square in between the trig ratio and the variable. So it's always important that you understand that that means cos x squared, not cos of x squared, and there is a main difference between the two. So going back to starting this particular question, what we need to now do is make cos x the subject. So rearranging this, we get cos squared x equals a half, and then what we end up with is cos x equals plus minus the square root of a half. So from this, cos x can either equal positive root a half, or cos x can equal minus root of a half. And what we're going to end up with is potentially more than two values. So looking at, so when cos x equals positive of root a half, we get x equals the inverse cos of root a half, which equals 45. So that's our first angle. So then if we just do a quick sketch of the cos graph, which between the range of 0 and 360, so that's 90, that's 180, that's 270, and that's 360, and we draw a horizontal line through root of a half, which is, let's say, there, and we get a value, although my diagram's a little bit bodgy there, so that works out to be 45 degrees from 0 for when the graph is at 1. So to work out this, the next interception point, that's going to be here, which is going to be 360 minus 45, which gives me an answer of 315. So for the answers for this particular expression, when cos x equals a half, x is going to equal 45 or 315 degrees. Now with regards to when x squared is, so let's just use a different colour pen. So for this situation here, I've got, so when cos x equals minus root of a half, and if I do the inverse cos of minus root a half, I get a value of 135. So again, if I do a sketch, and I could have used the original sketch, but I'm just going to start again just so we know where we're going. So from this, if I draw a horizontal line of minus a root a half, I'm looking for two intersection points between the range of 0 and 360. So again, this is 90, that's 180, this is 270, and that's 360. So again, our first angle, this distance here is 135. So then the distance here is also going to be 135. So to work out the second angle for here, all I need to do is 360 minus 135, which equals 225. So if I look at my 4 in total intersection points, they're all there. And again, it's very good practice that if you have got your answers scattered all over your solutions, is just write down your final answer. Now again, another piece of good practice is to write your angles in order. So, but again, it doesn't really make a difference. So we've got 45 degrees, 135 degrees, 225 degrees, and 315 degrees. And there is my final answer. So as I said, if you were to write your angles in, let's say, not so in numerical order, you won't lose marks as long as you have got all of the angles within that range. So moving on to example 4. Here what we've got is something that looks like a quadratic equation. Now this one is actually been factorized for us, which is a bit of a bonus. So again, this is where we are. So the first thing we need to do is recognize the range of values that we're wanting. Now for this, like we were solving a quadratic equation, we've either got 2 cos x plus 1 equals 0, or we've got that cos x minus 1 equals 0. Now if we were to solve this particular side here to start off with, we end up with cos x equals minus of a half, and if I do the inverse value of this, I get my first angle as being 120. So from this, if I just do a little quick sketch, which looks something like this. So here we can recognize that we get x equals, to find my second angle, which if we say is roughly going to be there, all I need to do here is do 360, take away 120, which gives me my second angle, because obviously this one here is at 120, and this is the second angle I need to find, which would then give me 240 degrees. So that's the first part of the equation kind of completed. So to work out the second, I'm going to do is use different colour pen. So working with this, we get cos x equals positive 1. So again, just doing a quick sketch of my diagram. Now if I draw a horizontal line of when it is at 1, I'm looking for this point here and this point here. So if I do the inverse cos of 1 on my calculator, but looking at the graph, it's pretty obvious what that's going to be. I'm looking for a value of 0 and 360. So if I just highlight all my solutions that I've got, and all I'm now going to do is write down the final answer in much sort of neater form to make it easier for whoever's marking my work to find the solution. So here I've got 0, I've got 120 degrees, I've got 240 degrees, and 360 degrees. Now again, although I've done 2 separate diagrams, again, feel free to just use the same one. It doesn't really matter. I've just gone for it, the fact that, just emphasizing the fact that we've got 2 different sets of solutions, and so that's why I've gone through the graph. But again, you will find your shortcuts in working how to do this, or you can use the method of cast to work out what your answers are going to be, and it's entirely up to you. You get no marks for drawing your graphs. Your first allocation of marks comes from you finding out the first angles from each of those 2 parts of the equation, and then you'll get a single mark for working out the other respective angles within the range that they've asked for. So for example 5, again, we find ourselves with a set of double brackets. So the first thing I want to do is make each bracket equal to 0. So starting off with this first one, we've got 3 sine x minus 1 equals 0. So rearranging this to get sine x the subject, I get sine x equals a third. If I then do the inverse function of that, I get 19.5 degrees. So again, doing a quick sketch of my sine graph within the range of 0 and 360, I get something that looks like this. If I draw a horizontal line through a positive a third, I can see that I'm looking for two solutions. So the first one is 19.5. So to find the second value, all I need to do is do 180 minus 19.5, which gives me an x value of 160.5. So there is my second angle for that. So then moving on to the second one, so here we've got sine x minus 2 equals 0. So making sine x the subject, we get sine x equals 2. Now the problem with doing the inverse, if we do the inverse sine of 2, our calculator will come out with a syntax error or a math error. And now one of the reasons for that is because there are no solutions. So if I just do a quick sketch of the sine graph between 0 and 360, this here is 1, this here is minus 1. Now if I was to draw a horizontal line through 2, you can see that there are no intersection points. So there are no solutions for this side. Now, although with practice you will come to recognize that in order for you to find values that for sine and cos particularly, that it needs to be a value within the range of -1 and 1, and if it's outside that range there's going to be no solutions. So always make sure that you are writing this, because examiners are wanting to make sure that you are checking to make sure that there are find any missing solutions that you may find. So if you do come to this, always make sure that you are writing that there are no solutions, because they are expecting you to solve both of these two brackets. So how you'd write your answer again is just writing a little bit neater. So x is going to equal 19.5 degrees or 160.5 degrees, and there to 1 decimal place. So then moving on to example 6. So as you can see with regards to this particular question, it solely resembles a quadratic equation. Now to solve a quadratic equation, what we need to do is make it equal to 0, which this is. So that's the sort of ultimate check we're looking at, and again we're still working with the same range of values of 0 to 360. Now what we need to do is attempt to either factorize or use the quadratic formula. Now if you're not liking the trig equation in this format, then one thing you could do is rewrite it. So if you just assume that y equals tan x, and one of the reasons why I'm using y instead of x is because x is already in the equation, then what this would look like is it would look like y squared minus y minus 2 equals 0. If I go on to factorize this, I get y minus 2, y plus 1 equals 0. And I end up with the solutions of y equals 2 or minus 1. Now if I then go back to replacing y with tan x again, then what I then factorize and get is tan x minus 2 and tan x plus 1 equals 0. So if you're not comfortable with factorizing when it's in its trig form, then obviously what you can do is some basic substitution. So you're replacing a letter with the trig function, then going on to factorizing it or using the quadratic formula. Once you've got your two values, so in this case what I've got is I know that tan x equals positive 2 or that tan x equals minus 1. So if I go on to, let's say if I just go on to solve this one here, so I've got the inverse tan of 2 equals x. So x is going to equal, in this particular case, it's going to equal 63.4 degrees to 1 decimal place. Now with regards to using the tan graph between the range of 360, so I've got asymptotic line at 90, that's going to be at 180, and then I've got another asymptotic line at 270, and I've got 360 there. So at the values of 2 within that range, I'm looking for 2 intersection points. So the first one, as you can see there, is going to be 63.4. So to find this second one, all I need to do is do 180 plus 63.4, which gives me an answer of 243.4 degrees. Now working with the second example, so if I just change the colour of my pen so you can separate between the two. So working with this here, I've got tan x equals minus 1. So if I do x equals the inverse tan of 1, I get x equals minus 45. And again, if I just do a not so accurate graph, which I've spotted a small mistake. Now, because my first value is minus 45, I'm going to just extend on the sketch. I'm just going to extend it to, so I've got some values on the left hand side. Because like I said, the calculator only gives me values that is going to be closest to the y-axis. So if I then draw my line of minus 1, which I'm just going to assume is there, and again apologies for the accuracy of these diagrams, they're not the best, but hopefully they do vaguely resemble the values I'm looking for. So as you can see, what the calculator is giving me, it's giving me this value here. So this is minus 45. And what that then tells me is that this distance from 0 is 45 degrees. So to work out this angle here, what I need to do is do 180 minus 45, which is going to be 135. And to work out this angle here, what I need to do is do 360 minus 45, which is 315 degrees. Now, again, as you can see, my answers are all littered all over the place. So in terms of work with my angles of what I found out, now the key thing to recognize here is that I've got a minus 45 degrees. Now this one is not going to be valid as it's outside the requested range in the question. So my final answer, which I know is not the best, but I'm going to write it up here, and if I get a different colour pen, let's go for this. So my final answer for this particular question is going to be x equals, and trying to write them in numerical order, is 63.4 degrees, 135 degrees, 243.4 degrees, and 315 degrees. Now, as I've mentioned, there is no expectation of you writing them in numerical order. So if you wrote your answers in the sort of way that you've worked them out, so here I've got one solution, was my second, this was my third, and this one was my fourth, and that would be absolutely fine. Like I said, if you have the time to write in numerical order, then that would be brilliant and easier for whoever's marking to allocate you the marks. So in this particular question, what we've got is we've actually got x as a function. Now in this, where it looks a bit sort of complicated, is the fact that we've got something in the bracket. So it's going to be very difficult for us to make sine x the subject. So for this, what I'm going to do, if I just assume that this bracket is equal to, let's say, an uppercase x. Now, as you can see, what we're doing to x is we're adding 15 degrees. So, and what this affects, it's going to affect this range here. Now, although my final answers need to be within the range of 0 to 360, because I'm adding something to x, what I'm going to do here is I'm going to add 15 degrees, and what I need to do is add, so whatever I'm doing to the bracket, I need to do to both my lower bound and my upper bound when I'm working out the respective angles. Now, although I'm adding 15, which is not a nice number, what I'm going to do instead is I'm going to add 90 degrees in both directions of the range. So what I'm going to do here is go from 90 degrees lower, so I'm going to extend the range and go to 450. Now this will make sense as we go up, but I just want to make sure that you understand of why we're extending this range. So because I'm adding 15 degrees, I need to I need to extend the range by 15 degrees in both directions. Now because the trig graphs go in sections of 90, I'm going to add 90 degrees. Just although it looks as if I'm going to be doing more work, it just makes my life a lot easier rather than dealing with parts of the subsections of the graph. So working with this, the first thing we need to do is make x plus 15 degrees the subject. So I've got x plus 15 degrees, so just making the bracket there, and that's equal to the inverse sine of minus 0.9. And if I type that into my calculator, I get x plus 15 degrees is going to be equal to minus 64.2 degrees to 1 decimal place. Now when I move to my graph, which I'm just going to do here, now if I just draw my, and again your graph doesn't need to be as accurate, as you can see mine is definitely not that straight, in which we've got 90 degrees, 180, 270, 360 and 450. And what I'm going to do now is draw my not so great graph like so. So here I've got my graph of sine x, and I've got the range between minus 90 and 450, and what I'm going to do is just choose a different colour. Let's go for light blue, and I'm going to draw a value where it's 0.9. So if I just draw a line here where it's minus 0.9, as you can see within the range that I want, I've got 3 intersection points. So this is the value that's given to me from my calculator, so it's telling me that this distance here is 64.2. So to work out the second set of angles, so this again is from where it's 0. So to work out this angle here, it's going to be 180 plus 64.2. And to work out this angle here, it's going to be 360 minus 64.2. So from the angles, what I've got is I've got x plus 15 equals minus 64.2. It's going to give me, the second angle is going to give me 244.2, and the third angle is at 295.8. Now I haven't finished the answer, but what I have done is I've found the 3 intersection points of solving that equation there, and now what I need to do is now make x the subject. So I need to get rid of the 15 by taking away 15 in both of these 3 angles. Now if I do that, I get x equals, now minus 64.2 minus 15 gives me minus 79.2 degrees. 244 take away 15 is going to give me 229.2, and 295.8 take away 15 is going to give me 280.8. Now as you can see, in terms of the answer of how they want the answers given to me, they want answers between 0 and 360. So I can kind of scratch this one off because it's outside the range, and these 2 angles are the only ones of the ones that I'm wanting. So I can discard this one as it's outside the required range. And there, so it's just these two answers here that are valid. So like I said, you might be doing extra work, but it's just in case, and making sure you're not losing or forgetting any angles that you have calculated by taking things a little bit too quickly. So moving on to, let's say, our next question. So let's have a look at example 8. So with example 8, what we've got here is what we call a double angle. So again, what I'm looking at here is, as I've got 2x, I'm going to do the exact same to these angles. So if I times both these 2 numbers by 2, 0 times 2 is 0. And if I times 360 by 2, I get 270. Now again, one of the reasons why we're doubling the range is that when I get to working out what x is, I'm going to need to halve it, so, or divide it by 2. So that's why we kind of need to do the opposite, so that we can then go on to working out the answer. So from this, what I can then do is I know that 2x is equal to the inverse cos of 0.4. And if I type that into my calculator, I get that 2x is equal to 66.4. Now the key thing, and what's very, very common that a lot of students do, is they then go on to work out what x is by dividing this by 2 and then use the graph. Do not do that. Do the dividing by 2 when you've got all the possible angles. So what I'm going to do now is I'm going to draw my cos graph. So that starts at 1. So that's up to 360, and then I'm just going to do the exact same, which looks like this. And all I'm going to do now is mark my intervals of 90. So that's 90, that's 180, that's 270, that's 360, that's 450, that's 540, that's 630, and this is at 720. And obviously this is at +1 and that is at -1. Now obviously you get, again, reminder, you get no marks on the state of your graph. Obviously mine's not brilliant at all. So let's have a look at finding the answer for this. So we're solving where it's 0.4. So if I just do a line of where it's at 0.4, so I'm looking for 1, 2, 3, 4 possible answers. Now what this has told me here is that this distance is 66.4. So what I've got is I've got 2x is going to be equal to 66.4, and if I find out what the other respective angles are going to be, it's going to be at 293.6, and the other one is going to be at 426.4 and 653.6. And again, all I've done is I've used that the distance from when it's at 1 is 66.4. So what I've done from there is worked out that this distance here is 66.4, that distance there is 66.4, and this distance here is 66.4 by adding, subtracting and using the graph to work that out. So from this, what I now need to do is divide all of these numbers by 2. And this is one of the reasons why we doubled the range of axes, so we can then work this out. So halving each of these values, what do I get? Well, I get 33.2 degrees, I get 146.8 degrees, I get 213.2 degrees, and 326.8 degrees, and there are all my answers. And as you can see, each one of those numbers is inside the required range of 0 and 360. So in our last example, what we're going to do is combine a lot of the previous questions together. So first things first, let's look at the range of x that we're wanting for our final answers, which in this case is 0 to 360. And as you can see here, we don't have a single x as our trig ratio, we've got a function. So to translate what range we're going to use for our diagram is I need to add 45 degrees. Well, in this case, I'm going to add 90 degrees, and then I'm going to double the range, the bound, sorry. So for this, the range I'm going to use for my diagram is 0 plus 90 doubled. I'm just going to keep it 0, and then this one I'm going to go all the way up to 900 to play it safe. Now in some cases I might be going a little bit excessive, but again, I'd rather be safe than sorry. And like I said, it's only a couple of extra sort of seconds it takes for me to just double check to make sure I've got every possible answer. So the first thing I need to do is make 2x plus 45 the subjects, and I do that by doing the inverse tan of root 3, and 2x plus 45 degrees gives me my first angle of 60 degrees, which is quite a nice angle. So if I go about drawing my graph like so, and if I wanted to I could go up to minus 90, and if I draw my intervals of 90, which might take me a while because I've got to go all the way up to 900. Like so. And now what I'm going to do is just do my asymptotes lines, just to give me an idea of where I'm going. And like I said, what I might be doing is doing excessive work. When you come to practice and you become a lot more sort of confident in this particular topic, you won't need to do as much work as what I'm doing as I'm explaining this. So don't feel as if it's not worth it, because like I said, it's just making you understand what we're doing. Now that was pretty bad, so let's just correct that. And we go like so. So again, your graph doesn't need to be ridiculously accurate, but it just needs to resemble what the original graph looks like, and also the numbers involved. So for this, if I used to use a different colour pen, what I need to do is do a horizontal line to where I think root 3 is going to be. So if I just imagine that this line here is root 3, and as I've used the calculator, it's told me that my first angle is 60 degrees. So this distance here from when it's 0 is 60 degrees. So to find the respective other angles, that's going to be, I need to add 60 to 180. I need to add 60 to 360. So if I just emphasize all of these angles that I now need to find. So I need to add 60 degrees to 360, 540, and 720. So from that, what I'm going to do is work all of those things out. So I've got 2x plus 45 is going to add up to 60, 240, it's going to add up to 420, 600, and 780. And I'm just going to quickly count. So I've got 1, 2, 3, 4, 5, and I'm looking for 1, 2, 3, 4, 5. So I've got all my angles. So now what I need to do is make x the subject. So the first thing I'm going to do is take away 45 from each of these numbers, in which I get 2x, and again if I just draw a line just so that we don't get confused with the graph. So I get 2x equals, and it's going to be 15 degrees, 195 degrees, 375 degrees, 555, and 735. And then all I now need to do is divide all of these angles by 2. So I've got x equals, as my final answer, of 15 degrees. No, I haven't. I've got, because I've not divided that one by 2. So I've got 7.5 degrees. I've got 97.5 degrees. Let me write this down again. So 97.5 degrees. I've got 187.5 degrees. I've got 277.5 degrees. And I've got 367.5 degrees. Now as you can see, that last angle is outside my range, so I've gone a little bit further just to make sure that when I'm doing this adding and subtracting and dividing by 2s or multiplying by 2, let's say, that I'm not missing out any answers. So there's no harm in going that little bit extra as long as you're sort of discarding the answers, so not valid as a possible answers. So my 4 possible answers are going to be those 4 there. So hopefully when you come to solving trig equations, you can hopefully relate it to one of the examples that we've done here. What I'd probably recommend that you do is go back to the start of the video, pause the tape where you've got all the example questions on screen, and have a go at those questions again yourself, maybe in about 20 minutes, so the answers aren't going to be memorized in your head, which I very much doubt, because then that in itself is a skill. So like I said, if you have any problems at all, feel free to drop me an email, and if you'd like a accompanying worksheet for this, then please feel free to drop me an email at 162maths@gmail.com.